so that, I mean, it will put some constraint to the parameters in the model. So this is, you know, a regularization technique. Okay, so in next chapter, when we talk about CNN, yeah, we will talk about GoogleNet, okay, which is the model Google created to classify, you know, images, okay, in the ImageNet competition, and in that model, they use this idea. Okay, they have like they actually have more than one output. They have like several additional outputs, and they use those additional outputs as auxiliary output to regularize the network. Okay, so this is like you know, another situation that you may want to consider, like you know, more than one output. Okay, so here, okay, let me show you the figure first. Where is it? Here. Okay, I mean, here in this figure, okay, not only we have two inputs, okay, but we have two outputs, okay. The reason for two inputs, I already mentioned, okay, previously. But for these two outputs, as I said, like this one is the auxiliary output, and which can be used for regularization purpose. Okay, so what do we do? Okay, that's for input. Okay, here is the code. Okay, the other part are identical to the multiple input one. Okay, so we only show the code that are different. Okay, so we have the output, which is the primary output. Okay, I mean, which is like pretty much the same. Okay, because it used the concatenation layer as the previous layer. Okay, but we have this one additional output. We call it aux output. Okay, and it has like one neuron. We call that aux output. Okay, which is like you know, use the second hidden layer as the previous layer. And the most important thing is in the model, when you create a model, okay, you can see you need to specify not only two input, but also two outputs. Okay, and so because you will only have like you will have like you know, loss function, right? You actually can have like a different loss function. When you compile the model, you need to provide the loss function for each output layer. Okay, so for the primary output layer, we use MSE. For the second auxiliary output, we use MSE2. And but we need to specify the loss weight. Okay, what is loss weight? Basically, loss weight, okay, is like a mechanism to put like a emphasis on different loss. Okay, so after all, the first output is the primary output, right? So this is the most important, you know, important one, okay, for the model. So we want it to be as accurate as possible. So we put 0.9. We want to put more emphasis on the first loss, and we put like only like 0.1. You know, a lighter emphasis on the auxiliary output. Okay. So of course, like you will also need to, you know, prepare your data so that like you have like you know, the ground truth. Now we have two very, how should I say, like two ground truths. But luckily, okay, because we are actually going to use the same value for the ground truths of these two outputs. So you can see that here. Okay, we don't need to do anything else. Okay, just in the model fit. Okay, we have two, training set A, training set B. Okay, and we just repeat the Y train as our ground truth. Okay, this is the ground truth for the primary output. This is ground truth for the auxiliary output. And we train this model for 20 epoch. Okay, and for the validation data, same thing. Okay, we have the validation set A, validation set B, and we repeat this validation ground truth like here. So that's it. So the other part, pretty much the same. Okay. So just want to show you. Okay. If you want to create a sequential model or like a feed-forward model, okay, or a simple one, okay, the simple models, okay, the sequential API is good enough. But if you want to create a complicated model, okay, then the functional API is a good one to use. Okay, it can accommodate like many complicated cases, and no matter if you can draw the model, pretty much you can use sequential functional API to create it. Okay, but we have we actually have a third way called Subclassing Api, okay, in Keras to build the model. So what, as I said, like I already told you, no matter how complicated the model is, we can use, as long as you can draw it, we can use functional API to create it. Why do we need a third one? Okay, the third model, third type of model construction, okay, subclassing API, is used to build what we call dynamic models. Okay, what do we mean by dynamic model? Okay, it is the case like when you do the model training. Okay, during the model training, you are able to change the architecture, the structure of your model. Okay? So the model structure can be changed dynamically, okay, during training. So it is very powerful, okay, obviously. And but at the same time, okay, it is also, easier to make mistake, okay, and it's more complicated, okay, than the sequential API or functional API, okay. So let me put it this way, okay. If your model is a static model, if you are going to use the same model architecture, during training, during inference, pretty much like just stay with the same model architecture. Okay, so that's when I say model is static. Okay, in that case, use depending on what the model architecture you have, like you can use sequential API or functional API. You don't use subclassing API. Okay, the only situation you need to use a subclassing API is when you want to create a dynamic model. Okay, which obviously is even for the state of the art deep learning paper that we have surveyed. Okay, there's almost no paper that is based on dynamic model. Okay, I'm not saying there's none, but the chance you need to use dynamic model is very rare. Let me put it this way. Okay, so So let me give you an example. Okay. So you can create a class, okay, wide and deep model. So okay, so it's subclass the Keras-7 model, and here, okay, we need to define this. We have two primary blocks. The first one is like here. The second one is the core function. In a diff, pretty much you specify what layers you have in your model. Okay, so you can see that we have like 30 neurons activation rerule. Okay, this KWARGS just means like that's like the input. Okay, the argument. Okay, and then we specify for example the first dense layer, second dense layer. Okay, and the main output, auxiliary output. Okay, so we specify all those here. But the relationship between these layers will not be specified until in the core function. So you see, so we have input A, input B as the inputs, and we have like this hidden one, which use input B. This part is similar to functional API. Yes, we use input B as like a previous layer of hidden one, okay, and so on. So, but the more important thing is we specify the relationship between between layers in the core function. Okay, of course for this example.